Hi, I'm Brendan Noble. How's the program?
Hi, I'm Hunter Shopping and I'm the builder.
Hi, I'm Stephen Danello and I'm the Research and Development Specialist.
What would happen if a gallon of water costs the same amount as a gallon of gasoline?
Poverty and unemployment would be worse than we've ever seen before.
One complex reason for this is overwatering your plants.
Overwatering with agriculture can cause the excess water to carry the pesticides into other water sources.
Water sources that are used for drinking, like streams, rivers, lakes, underground pipes, underground aquifers.
This could cause the rapid spreading of diseases and even death.
Boy, we have a solution for you. We're the Dogbots and we've created plants.
PLAN is a plant-locating autonomous nurturing technology.
Plant uses an ultrasonic sensor which sends out inaudible sound waves to make sure that the robot doesn't get too far or too close to the trough. It uses the IR optical sensor, which sends out light rays to double-check the ultrasonic sensor's readings.
As it moves along the side of the trough, which would be like a burrow in the barn, plant's color sensor sees a color tab in the dirt. This tab tells the robot what type of plant is going to be serving, since all types of plants need different amounts of water.
The first robot then sends a Bluetooth message to the second robot telling it to check the soil's moisture percentage. The second robot then moves the arm holding the moisture sensor down into the dirt, checking the soil's moisture sensor.
The soil moisture sends an electrical current through the dirt, and since water is conducting, the current travels through the soil, and the sensor can create a percentage of how much water comes up the soil.
Based on the type of plant it is, plant decides if it needs more water or not. If not, it moves on to the next plant.
But if so, plant fires up the Lego Mindstorm's pneumatic air compression pump. This pump pumps air into an airtight container creating air pressure. This pressure pushes water down up the tube and into the soil, where the plants can be watered.
Once done watering, the plant top goes back to a vertical position, stopping the water flow. Then moves on to the next plant to redo this process.
Plants green too because it gives the plants the right amount of water, not overwatering them. This saves money, conserves water, and reduces pollution.
And when creating plants, we used a lot of math and science. We had to study a lot about botany, the study of plants, and physics concerning our pumps and sensors.
For math, we have to calculate how much the robot should turn to get around the trough. We also have to develop separate routines for watering different kinds of plants.
That's right, let's not forget that you can buy plants for the low price of $9.99.
Want to grow plants, but you have to go. The Dogbots can make anything grow. All you have to do is rise up. P-L-A-N-T, that's all you need.
Okay, now we'll demonstrate the robot. So the robot is running along the trough and sends a color, a yellow color inside the trough. It moves the Bluetooth message and the second robot puts the arm down into the soil. The second robot then uses the pump to create air pressure inside the container and forcing water out until the soil moisture sensor senses there's enough water inside of it. The different colors have different readings that it needs. The red needs the most, and the blue needs the least. The yellow represents an average plant that needs an average amount of water. And it takes longer because the plants more water for the different types of plants. We have different sensors like the color sensor, the soil moisture sensor, the ultrasonic sensor, and the IR detection sensor. And it's watering this plant for longer because it needs more. This color needs more water, and it'll increase it until the splice doesn't reach the target value.
And it can be used in barns, greenhouses, and gardens.
And in farms it would be used like a furrow, and it could also be in any garden or in any other area. And it's taking longer because of increasing needs for such a plant that needs so much water.
30 seconds.
Yeah. Since we also have the cactus here to represent that won't give that one as much water. And we have this cup here to represent that for certain water sources. If it's like really moist, it won't water it. Even if it's like really moist, it won't water it. Only if it needs water.
And also, we can prevent a lot of pollution and conserve water because plant only waters according to the plant's needs, and it doesn't cause any growth.
Okay, great job. Big hand. I am the creative lead for the Galactic Hamsters, and most of my time was spent working with a display board, as you can see, and helping out generally wherever was needed. Our project is a game of robotic tag, essentially. These two robots in hamster balls are chased around by that robot, which is the chaser bot. It is on with flashlight, which catches the robots. The purpose of this game is to get the youth of this country, and honestly everybody else, excited about robotics, and to experiment with robots working together in a cooperative fashion. To explain the specifics of our robots, how they work, how they communicate, I give you the second member of our team, Sam.
Thank you. I'm Peter, I'm Sam, and I'm the programmer for the Galactic Hamsters. The chaser bot, which is this, is controlled by another robot, which is controlled by a person. That robot here has a rotation sensor, which controls the speed of the chaser bot, and also two touch sensors, which control its turning. In addition, the chaser bot also has an infrared beacon, which we'll discuss later, and a color sensor, which sees the colored piece of paper that's put on the floor, which gives you more time, which added to the 60-second limit. To explain what the chaser bot is chasing, here's Alex.
Hello, I'm Alex, and the bot at my feet is called a Hambot, hamster bot, Botster. It's a robot in a hamster ball. This robot that I'm holding in my hand is the master brain for these two slave bots right here. We're using a Bluetooth connection, like Sam said, and all this does is it sets the mode to easy or hard, and then it tells these two robots to go. These are completely autonomous bots. Now, we're going to run this game for you, and we would like Peter to narrate this game for us.
Thank you, Alex. This game, I forgot to mention, is called the Rampaging Robot Rodent Recovery, or ROBOR, I'm sure. And they're off, Alex. So set the difficulty, activate the hamster bots. And it's driven over a power-up. The power-up means he gets 10 extra seconds added to his time limit. And the green power-up appears not to be working. The yellow hamster bot is stuck against the wall, but the blue one seems to be running fine. Alex has freed the yellow hamster bot. And the hamster balls are working together today, it appears. Ah, he has caught the yellow hamster bot. The light sensor is flashing red. You might not be able to see it, but it is, letting us know that it's been caught.
These robots work by using a series of sensors. The flashlight is used to activate a light sensor that will tell the robots when they've been caught. The funny-looking green plate on the back of this chaser bot is a IR beacon. There is an IR seeker inside the blue hamster bot that is now rolling wildly around the ring, and it is used to, it's programmed to have the robot run away from the beacon.
They record our robot is called a slow word. The purpose of our robot is to learn from light to dark. It is very useful to change channel or a YouTube. Those are like what it is called.
to put the sock in right here. Oh yeah, we scored these gears. Our robot has 3 gears. First, the robot picked up the piece of clothes. It takes the piece of clothes into the color sensor and it detects what color it is. If it's light, it goes to the right and drops into the basket, and if it's dark, it goes left and drops into the basket. It repeats itself over and over until you stop it. The hardest part about building this robot was putting it together and using the gears, because sometimes the gears would go out of place and going around some wrong stuff. The program, the robot has ports, A, B, and C ports, and the B port was to move the arms up and down. The C port was to open, close the claws of the robot, and the A port was to turn the arms around. So first it went down, the claw closed, open, closed, and picked up the clothes. Then it moved to the color center. While at the color center, it stayed over there for 3 seconds to detect what color it is. Once it finds out what color it is, it goes, if it's light, it will go right. And then it'll drop it in the beat, and the arm will move back up, and it will start over and over. That's our robot.
I'm Josh Hager. I did the programming for the spot.
My name is Anthony Howell. I worked on designing and actually building the robot.
And I'm Spencer Gordon, and I also helped on building the robot. Our purpose of our thing was to sort cans from bottles and just make recycling. We got the idea when we were watching the show Dirty Jobs, and we saw how inefficient this recycling and trash plants were. They expose their workers to risk from fumes and such, and it's just very inefficient from having lots of people pick out materials. We started out with this, which would take bottles this way, you grab out a collar and drop down this into a bin, and cans would go this way into the crusher and be crushed. We had several different design changes along the way on the board. Along the way, we found that the claw was very inefficient and needed to be replaced, so it was more than the next part.
Okay, on the previous robot, we used several sensors, including bump sensors, limit switches, so when a bottle would enter the claw, it would know how to close, when to stop, and when to turn the valve on. On the newer robot, after we figured out this one was not very efficient on what we were trying to portray, we had brainstormed with several different ideas to this robot using an ultrasonic sensor so the robot knows something is there, and IR sensor so the robot knows if something, if it can have light pass through it, or if it's solid, such as it can. We use math, especially on this robot with gearing for speed, and for the can crusher we used math to understand torque so we can have enough power to crush a can.
So what this basic design is doing, that was the prototype model. Now we're on to this, bigger, better things. What we didn't do with that, we did on this. This is actually going to be inside of the recycling truck. So when they pick up your recycling, it's sorting as they're going to the plant. This cuts down all the workers that have to sort the plant, go through it. It saves money for the plant itself, and those workers just have to go in, grab it, makes their lives a whole lot easier. I'm going to start the demonstration now. So we're going to use ultrasonic, we're going to send out sound waves hit something and bounce it back until it's there. And we're going to use the IR stones, which will notice that this is transparent and tell this bottle to move on into the bottle dispense area. Now, if we use the can, the IR will pick up that it's a different reading and tell it that it's a can to do a different function. So when we put the can in, hold on one second. The flap opens up, which moves it off to this area. This area is where the can will eventually be crushed and look like this. Unfortunately, we overused the battery demonstrating to you guys. But yeah, and while this is all going on, the garbage truck will still be collecting everybody that's recycling, and it'll save time for lots of humans. That's why we believe this product will be great for recycling, and it's all great. Everything's recycled material and next parts. So that's our project.
Hello everyone, we're the Ecobucks from this Christian Academy. We are all in 5th grade. My name is Blake Ricker, and with me are Master Cusimano and Max Strada. Although we work together as a team, each of us has a main focus for the project. Max is our master builder. Max is the on the program and the creative guy and work on some concepts. Why do we participate in our lives? We obviously like to go others, we like to be creative, and we love to play cards, especially games 21.
As Blake said, we love to play cards, but none of us likes to deal cards. So we built Jack the Card Dealer. Jack deals cards from game 21. He'll find each player at the table and deal each player 2 cards, and then offer them to hit or pass. Now Matthew will tell you the building elements in more detail. Building the robot was quite challenging. It took several weeks to build, program, and test the robot until it worked reliably. Our robot holds a single deck of cards. It has a card dealing mechanism which consists of 4 gears, 2 motors, and 2 wheels. It has card guides to direct the card face down to each player. It also has 2 drive motors to maneuver the robot. We installed hit and pass switches. We also installed an ultrasonic proximity sensor which acts as the robot's eyes and finds each player. We programmed the robot to deal with 2 players, but if we change the programming up a little, we could have 3 or more players play.
I would like to tell you about some of the challenges we encountered building and building this robot. It was difficult to get the robot to deal only 1 card at a time. We came up with a solution that included adjustments to the feet of the rotation, and they used a belt strip back friction between the cards and the wheel. We also used a counterweight to minimize the weight on the cards. We also used the gear mechanism to increase the speed of the card building.
Let's give you a demonstration. Let's play 21. Matthew and Blake will take their seats. The robot's motors are turned on. First, the robot says 21 and 1. Then it turns over to Matthew and deals Matthew the card. Then it does the same thing with Blake. The robot says good luck and comes back to Matthew. Deals Matthew another card and says, please turn this card over. Now it does the same thing with Blake. Now the robot turns to Matthew and asks, hit or pass. Matthew pressed the hit button. And the robot dealt him another card. Now Matthew pressed the pass button. And the robot moved on to Blake and asked, hit me or pass. Blake pressed the hit me button and was dealt a card. Now Blake pressed the pass button. The blue light indicator is turned on to indicate the game is over. Thank you.
Was programming and some building?
Hi, I'm Dr. Mark Early. My key contribution to this team was building and writing the script.
Hi, I'm Dr. Wigton, and I worked on building and programming.
Our team of scientists has designed this product specifically for the elderly to cure medicine mistakes like skipping doses, taking the wrong pills, or taking too many. We use the STEM strategy in building this robot. The S in the STEM strategy stands for science, and some science we used was weight and friction. If there wasn't enough friction, the wheels would just spin, and if there wasn't enough weight, the robot would continue top heavy. The T in the STEM strategy stands for computer programming, stands for technology, and some technology that we use was computer programming and the color sensor.
The E in STEM strategy stands for engineering. We used engineering to build the robot to make it structurally sound and work properly. Also, we used it for using the motors. The M in the STEM strategy stands for math. We use math by equals and degrees. We use degrees by measuring how close the claw had how much the claw had to close, and we also use measuring to see how far it had to go there and back.
Some team accomplishments were communication, teamwork, cooperation, encouraging each other, and critical thinking.
Our robot, what it does, like what we said, it navigates your kitchen counter. It's got many color sensors, so it tells the different colored lines. When you start the robot, it says morning, noon, or night for what time of day your robot is going for your medication. At the end, it also says 1, 2, or 3, or how many pills you need to take after that.
That's all.
Hi, my name is Sarah Martin. Our team's name is ROBOfest. We're all 6th graders in the Southfield Academy, and I think this is the project we're making a global organization. From this project, I would like to organization we made produce some of the clothes and cars created by life. Hi, my name is Mary Joy, and I learned how to build and program an RCX car, and I learned how the touch sensors and the ultrasonic sensor work, and I also learned how to program a laptop work, and I contributed to the group by building and programming the RCX car and the school system.
Hi, my name is Shirisha, and I'm learning how to program the NXT and how to detect sensors and ultrasonic touch sensor work. And I contributed to this project by helping build a forklift and a gate opener. Hi, my name is Amy Short. I contributed to the group by helping with the electric car and programming it, and also some of the decorations. I learned how mobile learning is actually how to build it, and why and we're so worried about it, and when we're programming. Hi, my name is Priya Singh, and I learned how to use sensors and how they work, and I'm a white-collar user. Let's say going from Michigan to New York, your battery doesn't have enough charge to go all the way. You stop at a charging station, and you come in, and you go through the freeway where they charge your battery for you, or you could come to the parking charge where you could charge your old battery, and you could stop at the rest area because it takes a couple hours. Right now, the gate opener is over there, and the forklift are connecting with Bluetooth. And the RCX electric car, it's supposed to come from the freeway, but we just built this because it can't actually come from the freeway. The ultrasonic sensor sense it, and the gate opener closes it. And so now the gate opener is communicating with the forklift, and the forklift with Bluetooth, and the forklift finished forklift now. And it's following the black line until the aluminum foil tape, and it's taking the battery out. And now it's jacking up, and it'll turn around. And it follows the black line again to the charging station and sets it down, and it's it just swaps batteries. It doesn't charge the battery, because that takes a long time, and they have that you go to the private charge if you want to do that. It follows the black line again to the electric car, so it can put the battery onto the car. It's going kind of slow because it has to be really careful.